Hello and welcome to our brief presentation. I'm Courtney Crooks from Georgia Tech Research Institute. Today we're going to be discussing public response to geopolitical events and social engineering. Now for brief introductions to our research team. Here is my brief bio slide. Again, I'm Courtney Crooks. I'm a principal research scientist with Georgia Tech Research Institute and have been with GTRI since 2010. I'm a licensed psychologist, a Navy veteran, candidate with Emory University Psychoanalytic Institute, and clinically credentialed in health services psychology. My academic partner is Dr. David McGlinskey from Georgia Tech's Samnon School of International Affairs. Dr. McGlinskey is a computational social scientist. We are an interdisciplinary team with expertise in computer science, computational data science, international affairs, policy, social, and psychological sciences. We currently have 4 Georgia Tech students working on our project with us this summer. Annie Galani, Sam Jarkus, Sophia Martin, and Gaurav Seth. In the next few slides, we will talk a little about the foundations of our research, which investigates influence in the information environment. Our driving questions center on mechanisms such as, can external actors influence individual action by intentionally or unintentionally altering one or more sources of information? And does belief in different kinds of information result in different kinds of social behavior? We investigate the full spectrum of information and are interested in a range of information vectors. We operationalize types of information in the following terms. General information, in other words, neutral, accurate, or reliable, describes facts, observations, and socially agreed upon conventions. Misinformation describes unintentionally disseminated incorrect information. Disinformation describes purposely disseminated incorrect information. We also consider multiple factors in the information encounter. Our multi-theoretical approach assumes that people believe information for many reasons. For example, cognitive confirmation bias, concept studied in psychology, how the world is perceived, what we're talking about when we refer to political ideology, and social pressure to conform, such as social climate, groupthink, and other concepts studied in sociology. We develop techniques to capture and analyze trace data in an attempt to identify what we refer to as the tipping point, where information uptake leads an individual or a group to consider or commit to a particular behavior. This slide outlines some of our current research efforts. For the scope of this presentation, we will highlight the IVY and SNAP projects, which are currently supported through multiple internal mechanisms. IVY is the parent program through which topics relevant to national security and DoD, Department of Defense, are conceptualized. Some of this relates to COVID-19, but in a larger sense, it's about investigating the political psychology of social engineering influence, contributing to radicalization, polarization, and even pro-social behaviors. An operational goal of IVY is to enable our team through flexible and scalable tools and techniques to quickly ramp up and study breaking geopolitical topics with little to no warning. IVY applies a multi-theoretical, human-centric influence and response approach to study human technical systems and develop solutions to socio-political problems. Some of the basic foundations incorporated into the IVY project from the beginning have been psychoanalytic theory, social constructionism, ethnography, and psycholinguistics. We have built on these foundations as we have broadened our methodology and data collection techniques. This slide discusses our mixed methods design and describes how we combine qualitative and quantitative methods. These methods complement each other to create a robust data set and descriptive products. To develop our socio-behavioral model, we leverage multiple theoretical frameworks that we discover through conducting ongoing multidisciplinary literature reviews and developing an interactive behavioral diagram. Some examples of frameworks that we are currently translating into our inquiry protocol include social identity theory, relational regulation theory, and the dark triad or tetrad of personality. As we are examining each applicable theory, we draw key terms and concepts to build an integrated lexicon. Here are some of the examples of terms that we are currently using in our lexicon. The who, the how, and the why are standard framing questions of inquiry. We apply these investigating questions to our inquiry of the information environment. Who refers to targets, the actor and the object of the action. How refers to the method of action. Why usually refers to motivations for the action. We also add what to lend additional definition for translation to our protocol development, data collection, and measurement processes. These questions help formulate our driving research questions, measurement approaches, and independent and dependent variables. Next, we'll discuss open source data mining activities. Open source is publicly available data. This includes social media, but also all other kinds of media, electronic and written, that we can perform a variety of language analysis with. For example, sentiment is an emotional polarity ranked score based on available lexicons. Word clouds can also capture both frequency and sentiment in a simple but effective visualization. We can derive word frequency, sentiment, and cloud visualizations using a variety of custom or free text analyzers. We can also develop dynamic time series analyses given appropriate amounts of data. To enhance our social media data analytics capabilities, we developed a custom Twitter bot with 2 methods of Twitter analysis and tweet collection using Python. The first was an implementation of the official Twitter Developer API. The second is an experimental proof of concept, custom-written script that scrapes tweets directly from the website. We adapted a third-party script to generate word clouds. Tweets were stripped of special characters, stripped of stop words, and lemmatized, meaning they were reduced to the root word. For example, studied becomes study, and things becomes thing. The data was opinion mined using the NLTK Python library and placed into 3 buckets based on its polarity, positive, neutral, and negative. The word clouds were generated on a pseudo-weekly basis, and then an overall super cloud was computed, with many optional customizable features. Finally, we designed and compiled GUI executable using Qt and C so that everyone on our multidisciplinary team can collect data. The TwitterBot application chooses whether to use the API or the bypass tool based on whether a valid API key is provided. Again, we had 2 methods of collecting Twitter data. The first was to use the Twitter Developer API. This is the official way to access Twitter data. It requires approval by Twitter. You must create a developer account and apply for API access. With the free version of the API, you are limited to 7 days historical search, the latest 3,200 tweets of a given timeline, and various other rate limits. You can filter tweets by retweets, replies, search terms, and geolocation. With the free version, you cannot filter by date range. Using the official API is very fast, even with large quantities of data. The second method was using an experimental scraper that we developed as a proof of concept. In particular, we used the Twint Python package. The advantage is that there are no limits on historical search. You can filter by retweets, replies, search terms, geolocation, and date and time range. However, this method is much slower and gives inconsistent results. Here's an example of our word cloud output. The weekly output allows us to analyze trends over time. This data was collected by filtering for tweets mentioning COVID-19 related search terms, such as COVID, COVID-19, coronavirus, Wuhan virus, pandemic, and more. With the data we collected, we were able to observe other trends as well. On the left, you can see a plot of the subjectivity of a tweet, calculated using the Python package text blob, plotted against the tweet's sentiment. Interestingly, the plot creates an hourglass-like shape. On the right, we have plotted the daily percent change in tweets discussing COVID-19 conspiracies concerning Bill Gates, Chinese origins, and more. Another example of what we have been able to investigate is trends in sentiments in tweets. This graph looks at tweets with over 2,000 retweets and plots how the polarity of the sentiment towards the pandemic changes. Our brief presentation ends with our plans for continuing development of our project in the coming academic year. We plan to extend our behavioral diagram with additional theoretical considerations, develop methods of collecting data in addition to our social media analytics, and begin to validate our behavioral model. This will enable us to eventually refine our model to the point of integrating with additional automated data analytics, such as natural language and machine learning-based algorithms, time series predictions, and enhanced data visualizations. Thank you very much for your time today. We hope you enjoyed our brief presentation and look forward to future collaborative discussions. Please contact us with any questions at the email addresses listed here.